Hello and welcome to Bay College's Intermediate Algebra 105 online lecture videos. Today we're going to be talking about complex numbers. We're going to introduce what complex numbers are, and we're going to see initially where an application of complex numbers is required. Now if we look at something like this, and we recall in the previous sections, we can solve equations. I'm going to subtract 4 from both sides. So 4 minus 4, of course, that's 0, so x squared plus 0 is just x squared. 0 minus 4 is negative 4. Now, in order to solve a problem with a squared variable in it, we introduce a square root to eliminate the x squared. And when we introduce a square root, we got to remember plus or minus. So we have this equation here, x equals plus or minus square root of negative 4. And if we recall in the previous sections, when we had a negative under a square root, we said, hey, this is not a real number, so this has no real solution. Well, its solution actually lies in something we call the complex number system. So let's move over here and take a look at what the complex number system is all about. Here we have a diagram that explains the complex number system. Complex numbers are always in the form a plus bi. And there's different variations of a plus bi, which we'll go into here. But what the complex number system is it is the real number system as well as one additional unit. And it's called the imaginary unit, which we'll talk about a little bit more. Now, complex numbers break down into two areas. Imaginary numbers, which are a plus bi, where b is anything but 0. So it could be negative 1 or negative 1/3 or positive 5/2 or whatever. It's just a number, a coefficient here, not equal to 0, because if it was 0, it'd just be a, which we can see here. A is a real number. So these are our two breakdowns. A plus bi, where b is not equal to 0, is an imaginary number. And where b is equal to 0, well, that's part of our real number system, something we're familiar with. All right, now this can break down a little bit further. Our imaginary numbers can be pure imaginary numbers when a is 0. That means the a plus bi, if a is 0, it's just bi. It's a pure imaginary number. It contains this thing we call the imaginary unit. So let's look at some examples of what are complex numbers. Well, 4, well, that's a real number. If we put it into a plus bi form, it's 4 plus 0 imaginary units, which is a real number, just 4. If we look at 2i, well, if we put it into a plus bi form, it's 0 plus 2i, where a is 0. And that's just a pure imaginary number. This number only contains imaginary units, 2 of them. So we call this a pure imaginary number. And then this one here, 2 minus 7i, well, that's already in a plus bi form, where a is 2 and b is a negative 7. So it contains a real portion and an imaginary portion. And this is our definition of the imaginary number. So that's our imaginary number. This is a pure imaginary number, and this is a real number. So a pure imaginary number contains essentially both points, the real portion and the imaginary portion in this form, a plus bi. Now this format, a plus bi, very important, because when we do have imaginary numbers, we always want to express them in an a plus bi form, which we'll see some examples of. But first thing we want to do is we want to go over here and introduce what this imaginary unit is, which kind of takes the complex number system and simplifies it. It's really not that complex. Its name is kind of an injustice. The imaginary unit is the square root of negative 1. What's nice about this is we can always factor out a negative 1. And we call it I when we have the square root of a negative 1. So that's our imaginary unit. Well, sometimes we do math with our numbers, even in the complex number system. If I is the square root of negative 1, we're going to eventually have to add it, subtract it, multiply, divide it, and do all kinds of other things with it. So let's look at the powers of I first. If I is the square root of negative 1, I squared. Well, that's the square root of negative 1 times the square root of negative 1. That's what we do when we square something. And if we look at this, well, what happens when we square a square root? It essentially goes away. We end up with negative 1. The square root of negative 1 squared is negative 1. That's the unit being squared. That's the radicand, if you recall from previous sections. I cubed, well, that's just the square root of negative 1 times the square root of negative 1 times the square root of negative 1. Well, let's just assess for a moment. This portion here, if we just look at this, that's the same as this, isn't it? It's just 2 units of our I being multiplied together, which we already know is negative 1. So negative 1 times the square root of negative 1, well, the square root of negative 1 is just I. So this becomes negative 1 times I is just negative I. And now let's look at I to the 4th. Well, I to the 4th is negative, the square root of negative 1 times the square root of negative 1 times the square root of negative 1 times the square root of negative 1. Let's assess this for a moment. If we recall I squared, here's 2 units of I being multiplied together. That's negative 1. Here's 2 units of I being multiplied together. That's negative 1. Well, if we think about it, negative 1 times negative 1, a negative times negative is a positive. 1 times 1 is just 1. Now, we could do I to the 5th, and for time's sake, I'm not going to write out all these, but if we go back and look, if we add 1 more unit of I from I, we get negative 1. If we multiply another unit of I, we get negative I. If we multiply another unit of I, we get 1. Well, I to the 5th is the same as I to the 1st. I to the 6th is the same as I to the 2nd. It's negative 1. And this pattern, these first 4, will repeat forever and ever and ever. So what we do have to assess is just these. If we can memorize these 4 powers of I, we can simplify any power of I to the 1st, we have to know is just I. Square root of negative 1, which we just call I squared is negative 1, because we're squaring a negative 1 under the square root as our radicand. I cubed is these 2 together. I to the 1st times I squared. I times negative 1 is negative I. And I to the 4th is a positive 1, a real number, right? It's just 1. Well, let's look at some examples over here. What if I had something I to the 41st power? Well, I don't want to have to memorize all the way up to the 41st power, but what if I know the first 4, that's my tool for breaking this down. And honestly, if we just move back here for just a moment, I squared and I to the 4th are the power tools of our imaginary unit. And here's why. If I can find a number here divisible by 4, I know that it's going to be 1, positive 1, because I to the 4th is positive 1. Or if I find an even number that's divisible by 2 and not 4, well then I know it's going to be negative 1. And if we recall our rules of exponents, we can just kind of work it backwards a little bit. I'm going to call this I to the 40th times I. And use the power tools of even powers of I. If this number is divisible by 4, then it's equal to positive 1, because I to the 4th is 1. Because as we repeat through the powers of I, that's what we get. So this is actually equal to 1. Well, what's 1 times I? Just I. So I to the 41st simplifies to just I. Let's look at another example and use that same power again. Well, let's look at this. This one's already even, so I know immediately that it's either going to be positive 1 or negative 1. That's the nice thing about even powers of I. Now, if we look at the number 126, is it divisible by 4? Well, 4 does not go into 126 evenly. It goes into 124 and 128, but it does not go into 126, but 2 does. So my work's actually done here because I used that power tool. This number is divisible by 2 and not by 4, which means it's equal to negative 1, one of the even powers of I. All right, so hopefully that makes sense to you. Keep practicing using our Hawk system and practice those. Make sure you get really familiar with it. But what it comes down to is memorizing the first 4 powers of I, and then using the even ones. Even when it's odd, you can split it up. Move that odd one out and see what that even number is. Is it divisible by 2 or 4? Determine whether it's positive or negative, and which I is it, I or negative I. Same thing with the even ones. You know right away they're going to be real numbers. Which one is it, positive or negative? All right, now we have here the square root of negative 9. This goes back to our initial example when we had plus or minus square root of negative 4. Well, what can I do with that? I can always factor out a negative 1 from any number. So I'm just going to write this out as the square root of 9 times negative 1. This is equivalent, because 9 times negative 1 is still negative 9, so it didn't change its value. But what we can do here is use our rules of radicals, and split it up to square root of 9 times the square root of negative 1. Well, we know this is the imaginary unit. This is the definition of our imaginary unit. And the 9 is a perfect square. Well, that makes it easy for us, right? The square root of 9 is 3, and the square root of negative 1 is our imaginary unit. And if you look at this, this is in our a plus bi form. It just happens to be a pure imaginary number. Our a value is 0 because there was no real part to this. It's just 3 of these imaginary units. Let's look at this example here. What can I do when I have numbers outside the radical and numbers inside the radical? Well, the first thing we always want to assess is take out that negative value first. Factor this. This factors to, I'm just leaving the 2 alone, 2 times the square root of 36 and the square root of negative 1. Well, I'm going to take a shortcut because I know the square root of negative 1 is that factor of I. So just by essentially thinking of it this way, pulling out a negative under the radical is a factor of I. So you can just take the negative out. Notice no more negative. We just call it I. Now I can simplify this. Well, what's the square root of 36? It's 6. So 2 times 6 times I would be 12i. Again, this is in a plus bi form. It's just a pure imaginary number. A is 0. But when we have to write numbers in a plus bi form, sometimes they're not in that, not ready to go like the previous examples. If we look at this, there's some work to be done. We want to put it in a plus bi form, and sometimes when we're working in the complex number system, our final solutions may look like this. We have to simplify those into this a plus bi form. Well, one way to do that is to just say, well, I only have one denominator. I can split it up. I can write it as 6 over 3 and negative square root of negative 3 over 3. Now this is my a portion, and this is my bi portion. Well, that square root under the radical, I can just pull it out and call it I. And now we have a plus bi form. This is my a, my real unit, 6 over 3, which is 2. When we simplify, we always have to reduce our fractions. The square root of 3 over 3 does not reduce. It is what it is. So we have the square root of 3/3 I. This is my a, and this is my b, negative square root of 3 over 3, and the imaginary unit. So it is an a plus bi form. That's how we do it. We just split it up, simplify it, and now it is in an a plus bi format. We can also add and subtract. Now, if we look at this, maybe this looks like a binomial, maybe 6 plus 5x. You can think of it that way, but it's essentially the same thing as what we've worked with before, and that's combining like terms. That's all we're doing here. If you recall in one of the earlier sections of the semester, I think it was 1.4 or 1.7, we talked about adding or subtracting polynomials. Well, this is the same concept. We're just going to combine like terms. So let's put my real values together, my a values. I have 6 minus 8. Those are like terms. 6 minus 8 is negative 2. And then I have 5i minus a negative I. Well, if I'm subtracting a negative, it's addition. 5i plus I is 6i. And make sure, is this in a plus bi form? Sure it is. Negative 2 is my a, positive 6 is my b. So we have our imaginary number. And it was essentially combining like terms. A lot of students want to distribute that negative, and that's fine. That way you don't lose track of those signs. Don't make those sign errors. They're very common. We all do it at some time or another. Now, in the homework problems, you're going to see similar problems to this. All right? What this is asking you to do is solve for x or solve for y. Essentially, what it's asking you is, what is my a term? What is my b term in the complex number system? Well, just for a moment, let's just say x plus yi equals a plus bi. This is my form that I want it in. Well, if we look at this, what is my x? Well, x is the same as a. This is the real part of the equation. And y equals b. This is the imaginary coefficient of the equation. So when we see these problems in our book, that's what it's asking us to do. All right? So if we look at this, it's asking us to solve for x. Well, if we put our a pieces of this equation on one side, well, 2x minus 2, well, I have to bring it across the equal sign, so it's 2x plus 2. This is a. So I just solved this equation. What is the real portion of this imaginary form? Now, it's also going to ask us to take the same equation and solve for y. What is the y value, or what is the b value? Excuse me, what is the b value? Well, this is my b portion, and this is my b portion. I have to do the exact same thing. I have to bring them together. So I'm going to subtract 4 from both sides. Negative 8yi minus 4yi is what the b value is, or we want to know what the b value is of the imaginary unit. So if we combine these, we get negative 12yi is bi. What is my b value? Negative 12y. So b is negative 12y, and that's how we solve that. So a is this value, b is negative 12y. That's what you'll be asked to do in the homework example. This helps us do is understand what is the real portion of the imaginary number or the complex number. What is the imaginary coefficient of our complex number system? All right, thank you for watching the section on 6.6, complex numbers. In the next section, we're going to review multiplying and dividing complex numbers. Thank you for watching.